In the year 2003, a 9-foot great white shark vanished from the ocean without a struggle, without a witness, and without a trace, except for one small device strapped to her back that would spend the next 4 months recording the exact moment she was hunted down, swallowed, and digested by something far bigger than her. When that device finally washed up on a beach in Australia, the numbers inside had told a story so strange that scientists spent years arguing about what could possibly explain it. Today we're going to walk through exactly what that data showed, why the ocean's most feared predator turned out to have a predator of its own, and why the real answer is stranger, and more scientifically important, than any of the sea monster theories that followed it. The story begins off the southwestern coast of Western Australia, in the cold, deep water near a place called Bremer Bay. Researchers from Australia's National Science Agency were running a long-term shark monitoring program, tagging great whites up and down the coastline to understand how far they traveled, how deep they dove, and how they used the open ocean. One of the sharks they tagged that year was a fully grown adult female, healthy, in good condition, measuring close to 3 meters or about 9 feet long. In the eyes of almost anything else living in that water, she was an apex predator. The team nicknamed her Alpha, and they fitted her with a small satellite tag designed to record depth, temperature, and light levels every few seconds, then release itself on a set schedule, float to the surface, and beam its stored data back to researchers through a satellite network. This kind of tag does not transmit anything in real time. It is essentially a black box. Everything it records stays locked inside its memory until the day it detaches from the animal, rises to the surface, and finally uploads what it has been quietly logging for months. That detail matters because it means nobody watching from a boat or a lab actually saw what happened to Alpha. Nobody got a live alert. All anyone had was a shark that swam off into open water and a tag that would not report anything back for 4 months. When that tag finally separated and floated ashore near Bremer Bay, a recovery team collected it and downloaded the archive. For most of the 4-month record, the data looked exactly like what you would expect from a healthy adult great white. Normal depth changes as she moved through the water column, normal temperature readings that tracked the cool waters of the Southern Ocean, the kind of unremarkable pattern that thousands of shark tags produce every year. Then, partway through the record, everything changed within a matter of minutes. The first thing researchers noticed was the temperature. Just before the event, the tag was reading around 46 degrees Fahrenheit, consistent with the cold water Alpha had been swimming through. Within a short window, that reading jumped to roughly 78 degrees, a rise of more than 30 degrees. That is not a change you get from moving into a warmer current or swimming closer to the surface. A jump like that, sustained for hours, points to one thing. The tag was no longer in open water. It was inside the body of another animal. Right alongside that temperature spike, the depth readings told the second half of the story. The tag plunged rapidly from shallow water down to around 580 meters, close to 1,900 feet, in a short burst of time. That is not how a great white cruises. That kind of sudden, forceful descent looks like the movement of something powerful, carrying its meal down and away from the surface. For hours after that dive, the temperature stayed elevated, holding steady in a range consistent with a digestive process working on whatever had just been swallowed. Eventually, the temperature dropped, the depth changed again, and at some point the tag passed out of whatever had consumed it. It drifted back toward the surface, its release mechanism fired on schedule, and it rode the current until it landed on that beach near Bremer Bay. Put those 3 pieces together, the sudden heat spike, the violent dive, and the hours spent at a stable internal temperature, and there's only one honest conclusion. Alpha had been eaten, not scavenged after dying of natural causes, not injured and left to bleed out, but taken by something that swallowed her, carried her into deep water, and digested her. For years, this case circulated quietly inside shark research circles without much public attention. It was mentioned at conferences, discussed among specialists studying predator interactions, and folded into a growing body of evidence about how great whites treat other great whites. Then, in 2014, a documentary team brought the story to a much wider audience, framing it around the question everyone immediately wanted answered. When the ocean is big enough and dangerous enough to kill and eat an adult great white shark? That question opened the door to a lot of speculation, some of it grounded in science, and a lot of it not. The version that spread fastest online leaned into the idea of some undiscovered, monstrous creature lurking in the deep, possibly even hinting at an ancient predator thought to be extinct for millions of years. It is an exciting idea, and it is easy to see why it caught on. But when marine biologists actually sat down with the data, the more sensational explanations started falling apart one by one, and the evidence kept pointing back towards something far more grounded and honestly more unsettling in its own way, because it did not require inventing anything new. It only required admitting what a fully grown great white is already capable of. Let's start with the most obvious candidate people jump to: orcas. Killer whales are documented, confirmed predators of great white sharks. This is not speculation. In 2017, off the coast of South Africa, several great whites washed ashore with a single organ removed with surgical precision. Their livers, and researchers traced the kills to a specific pair of orcas known for targeting sharks in exactly that way. That event was so significant that great whites in the area avoided those waters for an extended stretch afterward. So orcas absolutely can and do kill great whites. The question is whether an orca could explain what happened to Alpha. The temperature data says no. Orcas are warm-blooded marine mammals with a core body temperature that sits around 97 to 98 degrees Fahrenheit, and they maintain that temperature constantly, the same way we do. If Alpha's tag had ended up inside an orca, the internal reading would have been close to that mammalian range. Instead, the tag recorded roughly 78 degrees. That is more than 20 degrees below what an orca's body would produce. It is not a small discrepancy that could be explained by measurement error. It rules out a warm-blooded mammal entirely. What does produce an internal reading around 78 degrees? A large fish with a specific kind of biology. Great white sharks are not simply cold-blooded animals that match the temperature of the surrounding water. They belong to a small group of fish, along with some large tuna species, that can keep certain parts of their body, particularly their swimming muscles and digestive organs, running warmer than the water around them through a specialized circulatory system. That elevated internal range typically falls somewhere between 14 and 25 degrees Celsius, which converts to roughly 57 to 77 degrees Fahrenheit. That lines up almost exactly with what the tag recorded. The behavior of the dive supports the same conclusion. Orcas need to surface regularly to breathe, and their foraging dives, while impressive, do not typically match the kind of prolonged, sustained deep dive recorded on Alpha's tag. A dive to 1,900 feet, held for an extended period, fits within documented great white diving behavior far better than it fits typical orca foraging patterns. And then there is the way the kill itself unfolded. When orcas hunt great whites, the pattern is distinctive. They isolate the shark, flip it into a state where it cannot fight back, and go straight for the liver, leaving much of the rest of the body behind. It is precise and targeted. Whatever happened to Alpha does not match that pattern at all. She was consumed largely whole, and the tag remained inside a digestive system for hours, moving through an actual digestion process rather than being left in a partially eaten carcass on the surface. That is simply not how orca predation on sharks tends to look. So if it was not an orca, and the biology rules out any mammal, what does that leave? The evidence keeps pointing toward another great white, just a significantly larger one. This is where people's instincts tend to resist the explanation, because most of us think of the great white as the undisputed top of the food chain, not as something that occasionally becomes prey for a bigger version of itself. But the science of the species does not support that assumption. Great whites are known to grow far larger than the animal we are talking about here. Alpha, at 9 feet, was a fully mature adult, but she was nowhere near the upper limit of what the species can reach. The largest verified great whites measured by researchers come in somewhere around 20 feet, occasionally more. One of the most famous documented individuals, a shark researchers have tracked and filmed on multiple occasions, comes in at just over 20 feet long and is estimated to be several decades old. Sharks at that size and age exist. They have been observed by divers, and their measurements are well recorded. An animal at that upper end of the species, roughly 16 to 20 feet and well over 2 tons, is entirely consistent with everything the tag recorded. An internal fish range temperature, a fast and powerful dive to deep water, and a prey item consumed largely whole rather than surgically dismembered. This is the conclusion the leading marine biologists involved in analyzing the case have pointed toward. Not an unknown species, not something waiting to be discovered in uncharted depths, but a known, documented, extremely large great white shark behaving the way large predators sometimes do towards smaller members of their own species. It is worth being honest here that this remains the best supported explanation given the available evidence, rather than an absolutely confirmed fact witnessed firsthand, because no camera was rolling and no human eyes saw the moment itself happen. Other shark researchers have pointed out, reasonably, that large sharks eating smaller sharks, including smaller great whites, is already a documented and unsurprising behavior, and that we should be cautious about dressing up an explainable event in mystery monster language just because it makes for a better headline. That caution is actually the most important part of this story. It would be easy to tell you that a mythical, undiscovered sea monster ate a great white shark because that version travels well online and gets people's attention fast. But that version is not what careful scientists concluded, and repeating it as fact would not be honest. The far more interesting and, frankly, scientifically valuable takeaway is this. Intraspecific predation, meaning great whites eating other great whites, appears to happen more than the public has generally understood, and it can happen even to a fully grown, healthy adult, not just to pups or juveniles, which is where most previous evidence of great white cannibalism had come from. Consider what that actually means for how we think about this animal. Alpha was not small. She was not weak. She was, by any reasonable measure, one of the ocean's most capable hunters, and she was still eaten by a member of her own species that outweighed her many times over. Within the great white population, there's effectively an internal hierarchy based on size, where the largest individuals can and sometimes do treat smaller adults the same way they treat any other substantial prey. The apex predator of the ocean, it turns out, is not always safe from itself. It is also worth pointing out why the megalodon-style explanation does not hold up biologically, since that theory is the one that tends to spread the widest online. The fossil record for that ancient predator is extensive, and it also tells us clearly that the species went extinct millions of years ago, that it lived in warm coastal waters rather than the deep ocean, and that its prey were large coastal marine mammals, not the kind of environment or ecosystem present at the depth Alpha's tag recorded. The deep ocean simply does not have the resources to support a population of animals that size, and if it did, we would expect to see other signs of it. Unusual bite marks on other large animals, unexplained population effects, something beyond a single data point. None of that evidence exists. What we have is one very well-documented dataset that fits known great white biology closely, and no additional evidence pointing toward anything else. None of this makes the story less remarkable. If anything, it makes it more remarkable because it means this behavior is happening in an ocean we already thought we understood, hidden from view simply because it happens in cold water, at depth, in places human observation almost never reaches. Researchers have pointed out that even with active shark monitoring networks running along that coastline, complete with acoustic receivers and years of tracking data, this single predation event still happened completely out of sight. Without that tag washing up exactly when and where it did, no one would have any idea it occurred at all. Alpha would simply be another tagged shark whose signal never made it back, one of many outcomes researchers already account for and rarely think twice about. That is really the heart of what this case teaches us. The ocean does not need an undiscovered monster to still surprise us. It only needs an animal we already know, behaving in a way we had not fully appreciated at a size we do not often get to see up close. The great white shark, the animal most of us grew up thinking of as untouchable, has rivals hiding within its own species, And most of the time, we will never know when one of those encounters happens because the only witness is usually the animal that does not survive it. So the next time you hear someone claim that a prehistoric sea monster is lurking somewhere in the deep, waiting to swallow sharks whole, you can share this story instead, because the truth turned out to be something science could actually explain, and in its own way, that is far more impressive than fiction. If you found this as fascinating as I did, let me know in the comments what you think really happened out there, and stick around because there are more stories from the deep ocean where this one came from.